Lesson 2.4, Domain and Range. We've talked about relations. A relation is any relationship between two values. It's typically represented by an ordered pair of numbers and defined by an equation, operation, or any other mathematical rule. A function is a special kind of relation. Each x value can only have one y value, and functions and relations can be expressed in many ways. We can have equations, sets of ordered pairs, graphs, tables, or mapping. The x values in a relation are known as the domain. The y values in a relation are known as the range. The domain is the set of input values. These are the values that we can choose and input into the equation in order to get a range value, which is the output values. So we put domain or x's in and we get range or y's out. The domain is also known as the set of independent variables. They're independent because we choose these. We can pick any domain element we want. Any value can be selected and input into the equation. And the range is the set of dependent variables because the value we get will depend on what value we chose. This is the calculated value. So we choose an x, we plug it in, and we solve for y. So for example, we're going to name the domain and range of the following relations and determine if they are functions or not. That should be negative, sorry, and this negative shouldn't be there. Okay, so our domain are our x's. So we have the set 1, 4, 2, and negative 3. Our range is our y's, so we have the set 3, negative 6, 5, and there's another 3, but since a 3 is just a 3, we only list it once. So 3, negative 6, and 5. If we want to find out whether or not it's a function, we need each x to only go to one y. So I have 1, 3. I don't have 1 going to anything else. So if I want, I can create a mapping, which we had discussed in a previous lesson. I could put my domain elements in the first box. I put my range elements in the second box, and I draw arrows to determine the relationship. 1 and 3, 4 and negative 6, 2 and 5, and negative 3 and 3. Since each of these have one arrow, this is a function. If we look at our second example, our domain, we have negative 3 again, and 2. And our range, we have 2, negative 6, and 0. Now, I can draw my mapping, but because I have less domain elements than I have range elements, I know that there's no way for one of these not to have two values associated with it, but I'll go ahead and create my map just to illustrate that. 3 goes to negative 2, and 3 goes to negative 6, 2 goes to 0. This right here indicates that it is not a function. Briefly, I want to discuss the three basic kind of pictorial types of functions. Okay, we can have a continuous function, a non-continuous function, and a discrete function. Continuous functions are continuous. They are lines that don't break. So if we graph them, the graph would look like this. Non-continuous are functions that have a break in them. So something in between. And then discrete would be just kind of a random collection of points. Examples of these. A continuous function would be water filling up a tub. If you have a tap flowing, it's not in your tub you have 1 gallon and then instantly 2 gallons and then instantly 3 gallons. It flows. So you have 0 and then over time it gradually increases to 1 and then gradually increases to 2 and gradually increases to 3, etc. So it would be a continuous function because the volume of the water in the tub is not instantaneously changing, it's flowing, and so it's changing slowly over time. A non-continuous function would be something like maybe distance traveled. But you stop for lunch. Okay, so you're traveling along, and this is time, and this would be distance. And you're traveling along, and then you stop for lunch, and so you're not gaining any new distance. And then later on in your time, you can pick back up and gain more distance. A type of discrete function could be something like the number of apples produced by a tree year to year. And this is discrete because you'll have various points. So in year 1, you may have this many apples. In year 2, you'll have this many apples. In year 3, perhaps this many. You're not going to have a flowing between the apples. You can't have parts of apples growing, turning into full apples. It's this many, that many.